Hello, everyone. And before the show gets started, I wanted to say that we know that there is an audio bug when I'm speaking. Luckily, when Ralph is speaking the majority of the show, there is no buzz, but there was for mine. We know that it's a problem. Hopefully, we get it fixed. It should be fixed by next week. And just wanted to get out ahead of everyone and say we're sorry. Hopefully, it's not too bad that it's unlistenable to. But yeah, it should be fixed now. So everyone give it a listen. Really great stories from Ralph. And we apologize for the audio distortion. But should be fixed. Everyone, thank you for listening. And yeah, on with the show.
Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome back to the program. I hope that you've been doing well and you are ready for today's show, because today, you may have guessed, we have Ralph Bond. He is our science and tech trends correspondent for Computer America. Very happy to have him, and he has selected a number of stories that I can guarantee you we have not covered on the show yet. They're really, really cool. You should definitely, stick around, check them out. And ladies and gentlemen, computeramerica.com is where you'll find everything, including show notes, where you can follow along with the video portion. Check that out at the website as well. But hey, if you just want to go back, kind of read the document in short, and click links, then computeramerica.com, it will have every single link that Ralph talks about. Every single story, because there's always a lot more to go and see. So with that being said, let's go ahead, just bring Ralph on and start this Friday off right. And once again, science and tech trends correspondent Ralph Bond. Hey, how you been?
I'm doing great. It's great to be back. Sorry about missing last week, but we had a blast in Sun River, Oregon with all the crazy grandkids and the big family get together. So that was great, but I'm very happy to be back again.
Back to normal, and as normal as this world gets. So, Ralph, you have picked a number of stories, and before we jump into them, for anyone out there who might be new to listen, let's tell them what we try to do here.
You got it. And if you're new, welcome. I hope you enjoy it. What Ben and I do every Friday is highlight 4 articles that show us key trends and developments in all things science and technology, including, of course, artificial intelligence. That seems to be everywhere. Mm-hmm. But robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, construction technology, space research, physics, you name it. But here's the key, folks, especially given the news this week. Most important of all, we're going to give you hope for a better future thanks to amazing breakthroughs happening every single day in the world of science and technology.
Absolutely. And let's go ahead and just start with story number 1. And for anyone out there who's listening, by the time that you hear this, you'll be able to go to the website and check these out as we talk about them. But for everyone out there who's simply listening to podcasts, we'll do our best to explain everything. So if you're just listening, that's okay too. We appreciate it anyway. And story number 1. Let's Ralph, couple, 1 week hiatus. You come back, first story of the day. You're starting out light, very simple, very explainable. Yeah, let's do some light fare of tiny silicon structures. Yes.
Yes, I forewarn you, geek alert. This is very geeky stuff. In fact, a couple of the stories this week are pretty mind bending, but this comes from techexplorer.com. Headline: Tiny silicon structures compute with heat, achieving 99% accurate matrix multiplication. And that one sentence has several, for me, what? I couldn't resist it because it sounded so curious. Compute with heat? What the heck? Well, let's get into this. And again, as Ben was saying, the show notes will give you links, images, etc., that'll help flesh this out for you. If you want to come back, if you're listening to us as a podcast, come on out and get those show notes and check it out and dive deeper. So let's get into this. Kind of give you a summary up front, then we'll get into the details. So to kind of give you a big picture right away, MIT researchers have engineered tiny, porous silicon structures that perform analog computations, specifically matrix vector multiplication using waste heat rather than electricity. And again, stand by, we're going to explain matrix vector multiplication because it's extremely geeky. But next point here, by encoding data as temperature differences. So you think about traditional computing as binary, right? 1 and 0, on, off, very cut and dry. They're talking about encoding data as temperature differences and leveraging inverse design. These devices achieve greater than 99% accuracy in simulations, offering a highly efficient method for such applications as thermal sensing and signal processing. Signal processing is a huge field, and it's a very difficult one to monitor and so forth. Now,
yeah, I look forward to seeing the applications for this because, it does not seem like traditional computers, but I'm sure for something this is going to be revolutionary.
You're exactly right. It really is targeting at a certain kind of application. And let's get into this matrix multiplication, which again, for me was a what? Here you go. Matrix multiplication is the fundamental mathematical technique machine learning models utilize, to process information and make predictions. So this is linked to artificial intelligence, again, large language models, so forth and so on. That's what we're talking about. And I'm going to explain a little bit more about matrix vector multiplication. It's the operation. Oh, this is so geeky. It's the operation where a matrix acts on a vector to produce a new vector. I bumbled that. Let me say it again. Matrix vector multiplication is the operation where a matrix acts on a vector to produce a new vector. It's one of the core building blocks of linear algebra. Oh, sure. I get it.
For the sake of time, I will say I completely understand as well.
Oh, good. Going on here, these tiny porous silicon structures that MIT has created could someday enable more energy efficient computation. So not only is it great for certain kinds of computational challenges, but it's also going to help with energy efficiency. So there's a win-win all the way around on this one. Now let's get into how does it work. In this computing method the MIT folks have come up with, input data are encoded as a set of temperatures using the waste heat already present in a device. The flow and distribution of heat through a specifically designed material forms the basis of the calculation. Folks, I warned you, it's geeky. Then the output is represented by the power collected at the other end, which is a thermostat at a fixed temperature. So you have the fixed temperature thermostat. It's encountering these variables of temperature, and that's how they're able to make computations. I know this is way out there, folks.
It's following another thing that we see in the show a lot, which is the idea of a robot is not humanoid robot, Jetson style. The idea of a machine is not always a machine. The idea of a computer is usually much broader than I think a lot of people are used to. I think this one, in terms of computation and calculations is probably much broader than, I think you and I usually attribute it to.
Oh, absolutely. Absolutely. And going on here, because the chips use heat instead of electricity, they could potentially first reduce energy consumption in certain types of computation, okay? Enable new architectures where waste heat is reused for processing. That part just fascinates me. And improve efficiency in environments where heat is abundant or unavoidable. Wow. And while the
Yeah.
MIT researchers still have to overcome many challenges to scale up this computing method for modern deep learning models, there's your AI, the technique could be applied to detect heat sources and measure temperature changes in electronics without consuming extra energy. Wow. And to wrap it up, this would also eliminate the need for multiple temperature sensors that take up space on a chip. Folks, I warned you, terribly geeky, but there's something very profound and important about what MIT have come up with here.
Yeah, just the idea of, once again, of using the waste heat, which I came into this thinking heat is generally just a byproduct, like something that you have cooling things in your PC. You have large companies siphoning off the entire drinking water supply of counties just to cool their machines. Like heat is kind of enemy number one, and it's cool that MIT is looking at that and saying this is an abundant resource. Can we use this in some meaningful way? And it looks like they're on the trail of it.
Yeah, exactly. And again, want to stress this. What MIT and the rest of this research team they're saying is not that your future desktop or laptop or whatever is going to run on heat. No, it's for very specialized applications.
Right, but the heat might one day, instead of just being something that is waste and you have to mitigate or manage, it could be something that can be utilized.
Exactly.
To improve efficiency. So hey, that's we love efficiency. So there you go. Story number one, right there. If you want to read more and catch up on that, because boy, that one could use a rereading. There's story number one. Check out the show notes. Story number two. If you scroll on down, they're all right here, and we're gonna go ahead and talk about, well, yeah, this is, once again, not waste. I'm sure the cells are doing something with it. But once again, just kind of tapping into, before waste heat energy and turning it into something useful, hey, maybe, as the title says here, untapped energy in our bodies. So, well, in cells.
Yeah, this next story continues part 2 of Geek Out. Because this is some geeky stuff here. From Popular Mechanics headline, scientists found an untapped energy source running through our cells. What? Wow. How could you resist that headline? I couldn't. So here we go. Scientists at the University of Houston and Rutgers University have identified a previously untapped energy source inside human cells. Okay. These two institutions collaborated on theoretical work. So stress, the trends and so forth. That's what we look at often. Very, very early research. This is a good example of that. So these two institutions collaborated on theoretical work showing that tiny ripples in cell membranes could generate electrical energy. Okay. Oh, and this is really going to be fun, Ben. You and I have talked about piezoelectricity a lot. Mm-hmm. That's where you generate electricity. Let's imagine something is squeezing up and down and up and down and up and down, and it's able to generate electricity.
One of the best stories we did about that was they wanted to install plates on sidewalks. So just,
that's it.
Yeah. People just walking would generate. Yeah.
That's exactly perfect. Boy, good memory. That's a great example of piezoelectricity. But what we're going to talk about here in this story, which I found so interesting because I'd never heard about this before, is something called flexoelectricity. So this discovery centers on flexoelectricity, a phenomenon where certain materials generate electrical charge when bent or deformed. And you might say, well, wait a minute, fellas, how is that different from piezoelectricity? We're going to give you the explanation. So a little side note on flexoelectricity and how it differs from piezoelectricity. So flexoelectricity is the effect where an electric charge is generated when a material is bent, twisted, or otherwise unevenly deformed. It occurs because the mechanical strain is non-uniform. So think about what Ben just talked about, where you're walking across a surface and that surface gently up, down, it's generating electricity. That's uniform. It's consistent. It's one kind of directional sort of thing. Flexoelectricity is when you're twisting, turning, stretching in uneven motions. That's the difference. And again,
I kind of get the feeling it's, the difference between like, you ever seen like one of those hand exercising things where it bends in a very predictable way versus like a stress ball where you just squeeze and deform and stretch in just in any imaginable way. Two very different mechanics, but very similar though, because, you're still kind of putting in the same kind of energy.
I think my grandchildren practice flexoelectricity with their bodies a lot. So again, piezoelectricity results from a uniform compression or stretching. It needs uniform strain, as we said. So that's the thing here. Again, flexoelectricity is the core behind this story. So the researchers found that cell membranes exhibit flexoelectric behavior, meaning they can produce electrical energy through tiny mechanical movements. The researchers, and this is going to get geeky again. I apologize. The researchers suggest that the churning, non-equilibrium environment of membranes surrounding cells could be enough energy to support biological functions such as, it's going to get geeky, folks, could support biological functions such as ion transport. Now, what I do with the show notes, Ben, and you know this, of course, but this is for new listeners and viewers, I will encounter something like that in an article and I go, ion transport, wait a minute, what's that? So I insert extra tutorial stuff into the show notes to augment the article. So a side note, ion transport refers to the movement of charged atoms or molecules, both of which are called ions, across a membrane or through a medium. It's one of the fundamental processes that keeps cells alive and allows everything from nerve impulses to muscle contraction to energy production. Who knew? I didn't know anything about ion transport.
I probably did in like the 10th grade, and then I immediately forgot it after I took the test, so which I failed. But yeah.
Yeah. And this insight could open new possibilities in bioelectricity research, soft robotics, artificial biological platforms, and energy harvesting at microscopic scales. Wow. Geeky stuff, folks, but fascinating, at least to me.
Energy harvesting at microscopic scales. So yeah, the Matrix could still be on, ladies and gentlemen, putting people in those big pods. Maybe that's what they're doing. But fundamentally, Ralph, like it's always fun that you bring some of these stories, and it's sometimes it's completely new ways to do certain things, and sometimes it's like it's like, oh, here's a whole new process that we didn't even know about, and here's how this works, here's how an organ works, here's how a system in your body works, here's how this mechanic works. And those are very fun because, Ralph, the closer that we get to understanding every part of something is how we get closer to actually replicating that. So
exactly.
Very crucial. Very, very cool. And again, just goes to show that nature is probably one of the most technologically advanced things out there. So very cool.
Oh, yeah.
So story number 2, if you're following along, story number 3, and we've talked about supercomputers a lot. They're very powerful pieces of equipment, but I don't think we've ever talked about pneumatic supercomputers, or I'm sorry, neuromorphic. Wow, I misread that completely. Not pneumatic. I was like, pneumatic. How's that? No neuromorphic. Never talked about neuromorphic either, so that's okay. Supercomputers on the show. So story number 3.
Yes, story number 3 is part 3 of our extreme geekathon this week. Okay, I'm going to warn you up front. This is another one of these like, what? So this comes from Interesting Engineering, one of my go-to sources many, many times. I love that outlet. Headline, world's first neuromorphic supercomputer nears reality with brain-inspired mathematics. Subhead, partial differential equations help solve real-world problems and are used to simulate weather patterns and model material behavior. Oh my goodness, that headline and subhead has a bunch of what? And we're going to explain, we're going to walk through all this for you. And again, the show notes will have all the links you need. Here we go. Researchers at Sandia National Laboratories, which is headquartered in Albuquerque, New Mexico, have demonstrated a new algorithm that allows neuromorphic hardware, that is, computers modeled after the brain, to solve partial differential equations. And again, I went, what the heck is a partial differential equation? So I've got a side note inserted in here, and I am going to go through it. Sometimes I just say, come to the notes and check out the definition, but I think we need to explain this for our audience right now. So a partial differential equation is a rule that describes how something changes in more than one direction at the same time. And if you're a real geek, go out there and look at some of the equations that when they're written, say, on a whiteboard, they're fascinating. Anyway, it involves a function with several variables, such as left-right position, up-down position, and time, and the partial derivatives of that function. Oh my goodness! So you're calculating a lot of things going on at one time, right? Left, right position, up, down position, and time, and partial derivatives of that function. Oh my goodness. Think of it as a way to model how things spread, flow, or evolve across space and time. Oh my gosh. Again, you got to go see what these equations look like. It's like mind-boggling.
Yeah, you kind of had me when you mentioned, at least I think it was mentioned here, the how this at the very beginning, simulate weather patterns. So high low pressure systems and how that will affect your day-to-day weather. Folks, like, it's how we didn't talk about this, Ralph, but since we were last on, Asheville got some snow where we're based, and I don't know, something about Google Weather. They get their sources from particular places. I'm thinking about weather and weather prediction, how that kind of affects, things in the world. And Ralph, about 6 days before the snow was supposed to hit, it was Google Weather was saying we were going to get 40 inches of snow.
Oh my gosh.
That totally could have been a possibility. I don't know. Weather's weather. By the time that we actually got it, luckily Asheville missed a lot of, kind of what happened to other places in the country that we feel for, but we got like 0.2 inches of snow on that day. So in 6 days, we went from 40 inches to 0.2 inches. And Ralph, you can imagine all the equations that you're talking about and all the prediction and all the modeling that goes into it. They worked with the best information they had, but it's so complex that even today, we can't tell the weather 5 days out. It's crazy.
It's a great comparison, and that's exactly what this kind of neuromorphic computer algorithm is aiming to deal with, that kind of stuff, the complexities of something like partial differential equations. So again, a little more about this. These partial differential equations that this neuromorphic computer that these guys have come up with, and the algorithm specifically, are absolutely fundamental in science and engineering. They are foundational in the modern scientific understanding of sound, heat, diffusion, electrostatics, electrodynamics, thermodynamics, fluid dynamics, elasticity, general relativity, and quantum mechanics. Ding, ding, ding. I think you've heard of that one, quantum mechanics, right? So, and to your point just a moment ago, from predicting weather patterns to designing aircraft wings, we had a story about that recently. Partial differential equations model how physical phenomena behave across space and time. Oh my gosh. Wow. Yay.
The problems that you'd say, I don't even know how to begin to tackle, calculating a lot of these things. And yeah, they're gonna at least build the hardware that you can start to build the algorithms to model this.
Yeah. And to go on here, it says why this major milestone combination of a neuromorphic computer, again, one that acts like your brain, is imitating your brain's function, with the ability to solve partial differential equations is important because they promise massive energy efficiency. There you go again, energy efficiency. So they promise massive energy efficiency, performing complex tasks at a fraction of the power used by traditional supercomputers. And until now, neuromorphic systems were thought to be good mainly for pattern recognition, not mathematical modeling. That's interesting, I thought. And I've got some more details on this breakthrough. You can come and check this out, but I will read this part here. Neuroscientists at Sandia National Laboratories developed an algorithm based on a well-known cortical network model. Side note, a cortical network refers to the interconnected web of neurons within the cerebral cortex, the brain's outermost layer responsible for higher order cognitive functions. So you can get into the show notes and learn a little bit more about this, but let's wrap this one up. Mm-hmm. Here's the implications of all of this, the implications for science, health, and security. So in mathematics and engineering, this could transform simulations in fluid dynamics, structural mechanics, and more. Brain health, so medical research, understanding computation in neuromorphic systems may shed light on diseases like Alzheimer's and Parkinson's. Pretty important. National security, agencies like the National Nuclear Security Administration could reduce energy consumption for nuclear physics simulations. Wow. And then to wrap it up here, neuromorphic computing is still early stage. So once again, folks, a lot of the stories we bring to you on Friday are early research, and this fits that category. So neuromorphic computing is still early stage, but this work lays the foundation for the world's first neuromorphic supercomputer. So very geeky, but very much in the category of trends to watch.
It's very strange when you have these very fundamental breakthroughs or innovations or, things that have so much implication that, you get, sub headlines like when you read the article of solving problems of math, health, and geopolitics. And it's like, you don't really know of many cross sections when it comes to math, health, and geopolitics. But maybe a neuromorphic supercomputer. So very cool. Like you said, it lays the pathway for the first one to be created. So we're not there yet, but hey, you need this step to get that step. So there you go. Story number 3, really cool stuff. And again, as always, check out the article. There's more there if you want to dig deeper.
Absolutely.
Yep. So story number 3. Story number 4. We're going to go, we're going to go lighter with this. And not lighter on the science, but light as in light. And we're going to talk about the brain. So, Ralph, what is this?
We usually, and folks, if you're brand new to the show, a lot of times the fourth story of the 4 we look at each week in detail is for medical research technology. And this one fits that category. It comes from Northwestern University, their news website. Headline, wireless device speaks to the brain with light. Subhead, implant could restore lost senses, provide sensory feedback for prosthetic limbs. Oh, wow. Okay. This is great stuff. You got to see the image of this device, but let's get into this here. In a new leap for neurobiology and bioelectronics, Northwestern University scientists have developed a wireless device that uses light to send information directly to the brain, bypassing the body's natural sensory pathways. The soft, flexible device sits under the scalp, but on top of the skull, where it delivers precise patterns of light through the bone to activate neurons across the cortex. Wow.
I wonder if this works for everyone's skull thickness, because I've been told I got to thicken. So I don't know if, I don't know. Very non-invasive. Love it, but very, very cool.
Well, yeah, and to your point, when you think about it, bone, even a thin bone, how powerful could the lights be on this little tiny device? By the way, if you're looking at our video, you can see that the device is put next to a U.S. a quarter coin, and you can see it's pretty small device. But how could it generate enough powerful light to pass through the bone of your skull? I don't know, but that's what they're up to here. In experiments, the Northwestern University scientists use the device's tiny patterned bursts of light to activate specific populations of neurons deep inside the brains of mouse models. There again, we have to owe a lot to mice. These neurons, by the way, are genetically modified to respond to light. So that's pretty interesting. First of all, they modified these neurons to respond to light and then put this device in the mouse experiments. And wow, that's pretty amazing. And get this, Ben, the mice quickly learned to interpret these patterns as meaningful signals. I have no idea how they pulled that off, which they could recognize and use. So even without touch, sight, or sound involved, the animals received information to make decisions and successfully completed behavioral tasks. What? How did they do that?
Yeah, it sounds, and I could be completely off base here, but whenever we humans kind of get information, imagine you're standing in front of two doors and you hear left door, right door. You see, a light blinking over one of the doors. Like, Ralph, we get our information through sight, sound, smell, touch, our senses.
Right.
This seems like it's adding like another one where it's just activating that part of the brain, not through sight, touch, or anything like that, but just light that is penetrating and activating neurons in the brain. That would be so weird because, again, it's not coming through one of your normal senses. It's just going directly to the brain and bypassing everything.
Yeah.
That's strange.
Oh, yeah, Ben, absolutely. To go on with what you're alluding to, it's fine. You can modify these neurons to respond to light, but how do you train or teach the mouse that when this light pattern happens, move to the right? When this light pattern happens, move to the left, whatever it was they were having the mice do, because it doesn't explain the behaviors that they're talking about. But my gosh, that part is more amazing to me than generating light patterns that go through the skull.
Yeah, to me, it would almost be like it would almost be like a spidey sense or something. It'd be a completely sixth sense that I think a lot of people kind of claim to have, or feel like they have, where you just have the information suddenly. It's just out of nowhere. You just realize, the one on the right or something. That's so strange and cool.
It is. It's very strange and it's very interesting. So to wrap this up, Northwestern University's technology has immense potential for various therapeutic applications, including providing sensory feedback for prosthetic limbs. That's wonderful. Delivering artificial stimuli for future vision or hearing prostheses. That's wonderful. Modulating pain perception without opioids or systemic drugs. Stop. That is super powerful in its potential. Can you imagine? And enhancing rehabilitation after stroke or injury, controlling robotic limbs with the brain, and more. I rest my case. If you're not uplifted by these stories, albeit all of them very geeky, I rest my case.
No, they're all worth bringing to everyone's attention, and the research that is still going on, is really amazing. What does it all mean? I'd be lucky to get 1 out of 4 right. But, Ralph, these are really cool. And, ladies and gentlemen, if you want to find out more, come out to Computer America and you can see all the show notes. Ralph puts these together. They're really cool, concise. And, yeah, computeramerica.com. It'll be right there. We even have a section entirely for Ralph Bond if you want to see more of his stories. But, with that being said, if you are following along, you may notice that if you scroll past this story, there's more stories, and it just goes to show that there's stories that Ralph does have to be quite discerning. It's not just he can only find 4 and that's it. No, for time's sake, we're crunching it, but right. Ralph, we can at least give the folks the headlines and they can come out to Computer America and find out more themselves.
Absolutely. So we've got this week, we usually have 4 honorable mentions. We have 5 because the first one I couldn't resist, even though this first one is 6 years old, but I stumbled on the story and I just thought it was so clever and so interesting. I wanted to share it. So the headline from CNN Inside Edition was Teen Inventor Solves Car Blind Spots with Brilliant New Technology. And you just really have to come out and look at the video and look at the story to understand what we're talking about. But this is a great example of a teenager coming up with this amazing, simple solution for blind spots. And the blind spot, there, I will say, if you look at the show notes, there's a picture. Say you're in your car and you have the part of the roof structure that connects to the body and it creates a solid thing. And this kid has figured out how to make it magically transparent. It's difficult to explain in words only. So come out to the show notes and check it out. That's a really cool one. Our next one comes from Inside Precision Medicine. There's a geeky outlet. Headline, ingestible bioprinter treats GI tract injuries from inside the body. Ben, we've seen this trend time and time again where medical researchers are looking at ways to go into the body in a non-surgical way to make repairs or to deliver drugs and so on. This fits that category nicely. Our next one comes from good old Interesting Engineering again. Headline, world's first cryogen-free superconducting motor promises 99.5% efficiency for aviation. Wow. Okay. Check that out. It's really cool. And that's actually a CES, Consumer Electronics Show related story, by the way. And the next one here, sciencealert.com, headline, new breakthrough to restore aging joints could help treat osteoarthritis. Wow. That's encouraging. And let's see, here we go. Our last one comes from phys.org. Again, that's short for physics.org. Headline, quantum tools set to transform life science, researchers say. Extremely geeky, but very cool stuff.
Yeah, no, it's really there as much at time as we could possibly give it. There are, really breakthroughs happening all the time in all these different fields. And everyone out there, I want to say thank you so much for tuning into Computer America. Ralph, thank you, as always, for putting this together. Amazing stories that people can go out, they can find out more, and they can go out to Computer America and find them all right there. So in the meantime, everyone, I want you to have an amazing weekend. We'll be back next week with even more stories. And with that being said, great show, Ralph, and everyone out there. I hope that you do something fun this weekend, and we will catch you next time here at Computer America. So until then, do something fun. Catch you next time. Bye, everyone.